Last years, technology has taken off in the aviation industry. It has developed the design of aircraft to be more efficient, more utilitarian, and the future of transport. We would like to use this video to share what a group of young apprentices believe the future of aircraft design and maintenance could be. Technology has always been used to increase efficiency and improve safety. With human factors playing a large part in aircraft accidents, we can use technology to help reduce incidences by streamlining and simplifying a personnel's workload.
Human factors encompass a wide range of psychological, physiological, and sociological elements that influence human behaviour in any given environment. In the context of aviation, these factors play a critical role in shaping the work of pilots, air traffic controllers, maintenance personnel, and other professionals involved in this complex industry. Fatigue, stress, communication breakdowns, human error, and organisational factors all play significant roles in shaping the performance and safety of aviation professionals.
Recognising these limitations is the first step towards addressing them. By investing in comprehensive training, fostering a culture of safety, implementing effective fatigue management strategies, prioritising mental well-being, and embracing technological advancements, we can overcome these limitations and propel aviation toward new heights of safety, efficiency, and excellence.
In the past, technology has evolved from paper maintenance manuals to floppy disks, and then to online manuals, which we use today. In today's world, the majority of maintenance documentation is printed out in the form of work packs and aircraft maintenance manuals, or AMM procedures, which are big, bulky, they're time-consuming, expensive, and unenvironmentally friendly. Handwritten entries can create confusion and mistakes if they're illegible. So companies have found methods to digitalise maintenance records using platforms like Orion and NGen, where the work pack is accessible to the authorised personnel whenever it's required, making entries far easier as they can be accessed from company tablets and computers.
Technology has gradually developed over the past few years, and we believe that the next stage of aviation involves augmented reality. AR, or augmented reality, is a technology that projects a computer-generated image onto the user views of the real world. We believe augmented reality has the potential to revolutionize how we perform aircraft maintenance, as AR has the capability to superimpose technical information in front of person view without distortions.
Augmented reality is currently shifting the process of designing, producing, and continuing airworthiness of aircraft. The traditional way of lining out a paint scheme of an aircraft requires precise measurements, reference points, and duplicate inspections. Now, with AR technology, we've made this process much faster and much more efficient. Using augmented reality, painters can project the paint scheme onto the aircraft, allowing them to see a real-time 3D image of the design scheme. This simplifies and saves time in creating bespoke, complex paint schemes that are one of a kind. AR is also being used in modern aircraft cockpits, particularly in the form of heads-up displays. Heads-up displays allow pilots to see crucial flight information directly in their field of view without having to look away from the windscreen. This reduces distractions and allows pilots to focus on flying the aircraft. The use of AR technology has already brought about significant improvements in efficiency, safety, and cost effectiveness. As the technology continues to evolve, we expect to see further innovative uses of AR in this sector. Here are some examples of how we think augmented reality systems could drive the technological advancement in the aviation industry.
A personal augmented reality device could be a game changer for the aircraft maintenance engineers, allowing them to access crucial information without having to take their eyes off the task at hand. Engineers could view pictorial data such as AMM figures, illustrated parts catalogues, and wiring diagrams within a 3D medium. This would allow engineers to see information they need in a more interactive and immersive way. For example, a personal AR device could highlight the actual part an engineer is identifying in the AMM, making it easier to understand and identify the correct part. Engineers could use an interactive touch system to pick parts in the illustrated parts catalogue. The personal AR device could then display the part number and automatically run a stock check to see if the part is available. If the part is not available, the device could perform an order for the engineer, making the process more streamlined. Another use of the AR device could be to highlight the actual wires in a wiring diagram and then map them within the 3D space of the aircraft so the engineer may identify and understand the system more clearly. The device could help with assisting the identification of mechanical damage. It could measure the extent of the damage, therefore deciding whether the component needs replacing. This could minimise human error and save engineers valuable time. We could use artificial intelligence within an AR interface to support predictive maintenance and early detection of issues through data analytics and machine learning. By integrating AR with sensors and data analytics, maintenance engineers can monitor the performance of the aircraft components in real time, detect any anomalies or issues, and then take proactive measures to address them before they become major problems. This could reduce the risk of unscheduled maintenance, minimize downtime, and lower the overall maintenance costs.
AR could enhance safety and risk management by providing real-time warnings and alerts for hazardous situations. With AR, maintenance engineers can receive real-time subtle warnings and alerts through their devices when they're working in hazardous environments like open fuel tanks. Additionally, AR can provide engineers with access to critical safety information, such as evacuation routes or location of fire extinguishers, which can further enhance safety and reduce risk.
At the moment, our team has proposed an idea to our company. We have thought of implementing an app that can store pre-saved pictures of the correct installation of these parts to improve the accuracy of critical parts installation. Once the engineer completes the installation of a critical part, they can use this app to take a picture of the area. The app can then use augmented reality to overlay the task area onto the picture that features the correct installation. Using artificial intelligence, the app can compare two pictures and spot any differences, flagging any potential errors. This can reduce the risk of installation errors as the engineer can quickly identify any discrepancies and make the necessary corrections.
The implementation of augmented reality technology to the design of the aircraft would revolutionise the industry in various ways. One major way that designers could benefit from this is creating new parts or modifying the aircraft that they are designing. With this device, designers would be able to collaborate more closely together as they'd be able to view what their colleagues are working on in 3D. This would raise the quality of information and communication that the designers are able to achieve, allowing them to make better designs. Another significant advantage of AR in aircraft design is that it could help to decentralise the design process. Designers could work with other designers from anywhere in the world, which would enable them to collaborate and share ideas more effectively. The device could also allow designers to visualise their designs on an actual aircraft rather than just working off of 3D engineering drawings. This would help designers to communicate better with engineers for any insights they might have. Designing products in a 3D medium using AR technology could also allow designers to transcend the limits of their body. For example, they could see through walls and visualise the entire aircraft, which would enable them to test their designs and concepts in real time using high-tech simulations of aircraft. This would greatly enhance the accuracy of design, as well as speed up the testing process, ultimately resulting in a more efficient and effective aircraft design.
AR can be useful in many ways for pilots. For instance, in the case of an unexpected event, an emergency procedure could be immediately displayed and integrate with the smart windscreen. These procedures could be in the form of visual AR, like arrows pointing at the relevant area that may require the pilot's attention. This could prove very useful for a less experienced pilot or a pilot in training. However, a poorly designed system could mean a distraction as opposed to assisting them.
Another application of how augmented reality and virtual reality could benefit the aviation industry is through selling of aircraft. Companies could design an aircraft in virtual reality for customers to configure and show a realistic image of how the stock aircraft will look in contrast to how the final product will look post customization. This gives the customer a better understanding of the modifications they are purchasing.
The potential for AR technology is endless, and it's exciting to think about the future of aircraft design and technology. AR has the potential to revolutionise the aircraft maintenance industry, making it more efficient, streamlined and effective. It's a promising development that we hope to be part of one day because of the vast impact it can have on the industry.